Hey, it's Doc Williams, and in this video, we're going to determine the empirical and molecular formulas of chemical compounds. This question tells us that a compound contains 12.8% carbon, 2.1% hydrogen, and 85.1% bromine. What are the empirical and molecular formulas given that the molar mass is 188 grams per mole? So let's start with the empirical formula. Whenever we have percent by mass, we can assume that we're working with 100%. That allows us to say that carbon is 12.8 grams, hydrogen 2.1 grams, and we have 85.1 grams of bromine. Now that we have our grams, we're going to convert grams to moles. So for each one, we're going to use the molar mass from the periodic table. Carbon has 12.011 grams per every 1 mole. Putting grams at the bottom allows me to cancel out grams and keep moles, which is 1.066 moles of carbon. Doing the same for hydrogen, we have 1.008 grams for every 1 mole. Canceling out grams gives us 2.083 moles of hydrogen. And for bromine, there are 79.904 grams in every 1 mole. Canceling out grams, leaving moles, we have 1.065 moles of bromine. The next step is to determine which of these has the least amount of moles, and then we're going to divide each of these answers by the one that has the least amount of moles. In this case, it is bromine that has the least amount of moles, so I am going to divide each one by 1.065. And the goal is to have a whole number for each of these, which will then serve as our subscripts. So bromine is 1, and I can look at carbon and tell that that will be 1. 1.066 divided by 1.065 can be rounded to 1. And 2.083 divided by 1.065 is 1.95, actually 1.96, and this can be rounded to 2. So our subscripts for our empirical formula is C1, H2, and Br1, which can also be written as CH2 Br, because whenever we have a subscript of 1, it is understood. This is part of our answer, which is the empirical formula. So now that I have the empirical formula, I am going to determine the molar mass of this empirical formula. So I'm going to multiply the masses on the periodic table by the number of atoms I have for each element in the compound. So for carbon, I have 1 carbon at 12.011 grams, which is going to give 12.011 grams per mole. I have 2 hydrogens at 1.008 for each hydrogen, and that will give 2.016 grams per mole. And bromine, I have 1 of those, and each one has a mass of 79.904, which is 79.904. If I add all of these together, we have a molar mass of 93.931 grams per mole for each CH2 Br. Now, this is the molar mass for the empirical formula. And remember, the empirical formula is like your backbone, your least denomination for the subscripts for a compound. And based on the mass of the compound, it may be a multiple of this empirical formula. So in other words, it can be C2H4Br2. In order to determine that, we're going to use the molar mass of the actual compound and divide that by the mass of the empirical formula, which is 188 grams per mole. And this is the molar mass of the compound that we're trying to figure out the molecular formula for, not the empirical formula, but the molecular formula. And we're going to divide that by our calculated molar mass for the empirical formula. And we see that 93.931 will go into 188 2.001 times. So this is 2. This 2 tells us how many times we're going to multiply the subscripts in the empirical formula. So this means that I'm going to take each element and multiply the subscripts by 2. And this will give me C2H4Br2. And this is the molecular formula for this compound. As always, thank you for watching.